Okay, let's talk about the second part of 6A, which is distributions. And when we're looking at the distribution, and we're normally going to be looking at a histogram, or we're going to be looking at some kind of a line chart that goes with this. There are three things that we are going to look at. We are going to look at the shape of the graph, which is also called the shape of the distribution, the typical value, and we'll explain a little bit more of that, and then the variation of the data value. So we're going to take each of these piece by piece, but let's start with looking at data. Sometimes it is easier if you have a histogram or if you have a data like this, that it can be easier if you just look at a curve that is fitted over the top of the data. Kind of like if you were doing a line graph, but if you were doing it more smoothly. Okay, so you can do this to any graph. I've got 1, 2, 3, 4 graphs here, and what I want us to do is I want us to sketch a smooth curve over the data. So we want to start here, and it doesn't have to be exact and it doesn't have to be all that close, but you want to make sure that you have a curve that fits most of the data. Okay. Here you're going up, you're coming back down, you're going up, and you're coming back down. And here you're starting low and you're getting larger and larger until you hit that. So by looking at these curves, sometimes it can be easier to tell information about it. So let's start looking at the shapes. There are two things when we want to consider when we're looking at shape. We are going to look at modes, which are peaks in the graph. Now, why is it called modes? Let's think about it. The frequency is the number of data values. So the higher the bar, the more data values that are in either that bin or that individual. So that means that value is going to be a mode. Okay. So of course we have fancy names for everything, but these are prefixes that you're used to before. So we've got unimodal, which is one peak. Think unicycle, unicorn. Bimodal, two peaks. Bicycle, I don't know, whatever. Multimodal, you can use for two or more. It's normally going to be used for more than two, but two is more than one. And uniform distribution is when there really are no peaks. Now, I did not do a graph for that, but I do want to show you what a uniform distribution looks like. So if you have a graph, and there are no peaks, that means everything is the same. So this would be uniform. In addition to modes, we want to look at symmetry, which is the shape of the graph, symmetry or skewedness. Okay. And we're going to talk in a little bit later about how the mean, mean, and mode are related to the shape of the graph and the typical value. So when we get into typical value, we're going to talk about that. Okay, so we have symmetric. And of course, symmetry means that if you were to fold it on itself, that you would get the mirror image. This side is the same as this. So this one is symmetric. Left skewed means that the values are more spread out on the left side of the peak. So you've got your peak, and notice it's all clumped up over here, but it's really spread out over here. Right skewed is just the opposite. It means that it is more spread out on the right side. Now, the way I remember this is one of those things that I have difficulty with. So the way I remember it is I think, okay, skewed is very close to ski. Which side of this would I want to ski down? So I want to ski down the left side here. And here I would want to ski down the right side. And I'm going to show you another way in the review that I think about it. Okay, so let's see if we can apply this to these four graphs up here. we are going to look at each of these A, B, C, and D, and we are going to do the modality, which is how many modes there are, and then we are going to look at the symmetry or the skewedness. If I look at this, I can see there is one peak, which makes it unimodal, and it is roughly symmetric. It's not ever going to be exactly symmetric. So for graph A, I am going to write that this is unimodal. Whoops. And that it is symmetric. Okay. If I look at graph B, I can tell there is one peak and there is more data spread out on the right. So that is going to be right skewed. So again, B is going to be unimodal. And it is going to be right skewed, which is the same as skewed right. Now graph C is kind of interesting. First of all, because it has two peaks. But notice these are the same height, and I could argue that if you folded this in half, it would almost be the same. So I am going to call graph C bimodal, and I am going to call it symmetric. Then lastly, you can see there is a single peak, so it is unimodal, and the data value is spread out more on the left side of that peak, so I am going to call that unimodal, and I am going to call it left skewed. Okay, so let's see if we can do some of these. Now, it's really hard for me when I am trying to decide modality and symmetry. I need to look at a graph. Okay, so let's see what it says here. For an exam on calculus, most students scored very high with only a few doing very poorly. So is this distribution likely skewed left, skewed right, or symmetric? All right, well, let's see. What are the grades on a calculus test going to be? They're going to go from 0 to 100. And then the frequency is going to tell us how many students earn that. So it says most of them scored very high. So let's say this is 50, and let's say this is 75, and this would be 25. Okay, so most of them did really well. So I'm going to say that most of them got in between the 75 and the 100 range. Then it says that only a few did very poorly, which means that this is probably going to continue going down until there were just a few that did very poorly. So now if I draw a line or draw a curve to kind of fit this data, I can see that it is going to be skewed left. Okay. Now, it doesn't give me enough information to find out if it's multimodal, because if I got like 10 people got 100 and then 10 people got 78 or whatever. Okay. All right. A restaurant tracks the number of customers at given times during the day. Is it likely that the data is unimodal, multimodal, or uniform? Okay, now we had a really good discussion in class about this, and it depends on the restaurant. And how many meals it serves. Okay, if it's open for breakfast, lunch, and dinner, okay, so breakfast, lunch, and dinner would probably have 3 modes. For just breakfast and lunch, 2 modes. Now, there's another one that was brought up in class that I hadn't even thought about, something that's open 24 hours. Then you would have breakfast, lunch, dinner, and after the bars close. It's like Katz's Deli. Oh, I don't think Katz's is even here anymore. Okay, so it's going to depend on the restaurant and how many meals it serves. But however many meals you decide, let's go ahead and graph one. Let's do one that is open for breakfast, lunch, and dinner. So let's say we would have a peak at 9 a.m., 12 p.m., and 6 p.m. So you would have a peak here, and here, and here. And I don't know how, if it's more popular for dinner or whatever. Okay. All right, well, then we did some practice, and you need to state whether you expect it to be symmetric, right skewed, or left skewed, and explain it may be helpful to sketch a graph. I always sketch a graph. So let's look at the heights of a sample of 100 women. Okay. As I'm sketching a graph, of course, this is the frequency, and this is the height. Now, I know that the average height is 5 foot 4 inches. It may have gone up a little bit. But as I said, I'm an outlier. I'm 6 foot 3. But there are people that are 4'11" and people that are 3 foot 5, so I don't know. You could argue whether this is skewed right. Okay, if you thought there were more people, even though this is the average, you could say that this is skewed right or it's skewed left. I could argue it either way. So I think you could argue symmetric or skewed right. All right, the ages of all CEOs in Fortune 500 companies. Okay, so we're going to be talking about their age. So now this is something, and this is probably changing with all the tech companies. The CEOs of companies is probably coming down. But it used to be you worked your way through a company and, an established company and worked your way up to CEO. And that probably didn't occur until you were about 60. There were probably very few, if any, 20-year-old CEOs and 80-year-old CEOs. This is probably where the peak is. I would say it would go down like that, and I don't know. I think you could argue it one of two ways. Okay. And there are going to be very few over there. So I think you could argue this in a lot of different ways. And the weights of each banana in a shipment. Okay, now this one was intended to kind of be a little bit different. I would call this one skewed left. The weights of each banana in a shipment. Okay. The average banana is going to be 10 ounces. Okay. Probably most of the shipment is going to be like that, and then there are going to be a few outliers, so I would call this symmetric. Okay. Now let's talk about the modality, the heights of a sample of 100 adults. This is different than the one about the 100 women because we've got to have in here the women and men. So we're going to have heights. We know 5 foot 4 inches is the average for women. 5 foot 7 is for men. So we are going to have I would say it would be bimodal. We're going to have, and this is not going to go down much in between because you're going to have an overlap from both. But I would say this is bimodal. The weight of newborn babies, I don't know. Probably the average is probably about 7 pounds. I really don't know. But you're going to have, most of them are going to come in at normal weight. You're going to have the larger babies, and you're going to have the little preemies that are less than that. But I would say this is unimodal, that most of them are going to get really close to that 7 pound. Okay, so let's talk now about typical value. Now, typical value is the center of the distribution. Now, this is really important. The typical value is the center of the distribution, which means it is the center of the data values, not the graph. Whoops, I'm sorry, you can't see that. And it is related to the mean and the median. Okay. All right, now here's what we know. We know that the peak, this is going to be the mode. In all of these graphs, because that's the frequency, so this is going to be the mode. The highest value is going to be the mode in all of these. If you are dealing with symmetry with a symmetric value, then the median or the mean and the median are all the same thing. So the mode, the median, and the mean are all the same. So that tells you that the mean is the typical value. If it is left skewed, if this is the mode, the median is to the left of the mode, and then the mean is over here. So the center of the data is the median. The median is the center of the data. If you are right skewed, the median is to the right of your mode, and the mean is to the right of that. So your center is your median. Now why? Because it is the center of the data values, not the typical value. It is the center of the data values. Remember, if you're counting in from both sides, the median is what's in the middle. Okay, so let's see how this works on here. All right, so what we've got here is the histogram shows the number of goals scored in 2012 by women who were first-year soccer players in Division III. It is reported that the graph has a center of about 16, which means 16 was the typical number of goals. Okay, so let's do just a really brief curve and see what we've got going on here. So I have got this coming up, and then down like this. So this is going to be skewed right. Now I'm going to go into some detail here about why 16 is the typical number of goals. Okay. Well, let's see what we've got here. Well, how many data values do we have in each of these bins? Between 9 and 12, we have 5. Between 12 and 15, there are 9. Between 15 and 18, there are 6. There are 6 here. There is 1 here, and there is 1 here. So we have 14, 20. So there are 28 data values. Okay. If we were going to find, since it's right skewed, the typical value is the median. So with 28 data values, the median is 14 from the low or high. Okay, so if I scoot in 14 values from either end, I end up right here. There are 14 values to the left, 14 values to the right. So since it is skewed right, the median is the typical value. Now, these are bins, so we don't know exactly what is in here. But if I look at a center of about 16, if this is 15, this would be my center of distribution, would be right here, which means I would have 14 to the left and probably 14 to the right. Do you think 15 is also reasonable? Well, yes. Now, one of the things I want you to remember is this is of the data values. Notice it is not halfway in between the number of goals. It is how many, what is the total of the frequency to the left and the frequency to the right. If you were looking at right in the middle of the graph, it would be up here. But then you'd only have one data value to the right, and you'd have 27 values to the left. So looking at this graph and following this reasoning, is 15 reasonable? Yes, it's in this same bin, so it could be 15 or 16. But let's look now at 18. Is 18 reasonable? 18 is going to be in this bin. So I would say no. That would mean there are 20 data values to the left. So that's not going to work. Okay, let's look at another one. Let's look at 12. 12 is in this bin. Is 12 reasonable? No. Only 5 values to the left. Now this one we have specific information on, so it's easy to tell. But you might not be able to. Now a reasonable number, if I wanted to find a reasonable number, I would think 15 works, I would think that 16 works, 17, 18 is not going to work. I would say that the typical values, my judgment would be between 14 and 17. But again, that's going to kind of be a judgment call. Okay, and I'm going to switch videos.